Hi everyone, myself Dr. Sridevi. In this video lecture we are going to learn about frequency domain filtering. So first we have to know what is a frequency domain filtering. So it is a signal and image processing technique in which the data is analyzed and modified based on its frequency components rather than its spatial or temporal values. So here in frequency domain filtering, the image is processed and modified by its frequency components rather than its pixel values directly. So this process converts the signal from its original state to sum of sine and cosine waves of different frequencies. So low frequencies, high frequencies. So it represents smooth areas. Low frequencies represent smooth areas of an image. High frequencies represent edges, noise and sharp transitions. By controlling these frequencies, we can smooth, sharpen or enhance an image. So here the image transform is represented in the form of a discrete Fourier transform. So here we have to consider the filter transfer function h of u comma v, Fourier transform of input image. Here g of u comma v is equal to h of u comma v into f of u comma v. H of u comma v is the filter transfer function and g of u comma v is the filtered image in frequency domain. So here the steps are pre-processing Fourier transform. First one, pre-processing, that is multiply the image by minus 1 the power x plus y to the center of the spectrum. So here convert the image from spatial domain to frequency domain, and filtering or multiply f of u comma v with h of u comma v removes or enhances the selected frequencies. Inverse Fourier transform convert back to spatial domain. Post processing that take the real or undo centering. This type of frequency domain filters are low pass filter, high pass filter, band pass filter. It removes high frequencies, is called as low pass filter, used for smoothing and noise reduction, and high pass filters are remove low frequencies. It is used for edge enhancement and sharpening. Band pass filter or band stop filters, it allow or block specific frequency ranges. So here according to the diagram given, pre-processing, Fourier transform, filter transfer function, inverse Fourier transform and post-processing. These all are the combination of frequency domain filtering operation. The previous diagram shows an image is processed by using frequency components instead of a direct pixel values. So input image f of x comma y, the original image is in the spatial domain. The pixel values depend on position x comma y. Basis of filtering in frequency domain is first one, multiplying the input image by minus 1 to the power x plus y to the center of the transform. Then compute f of u comma v, that is Fourier transform of the image. Multiply f of u comma v by the filter function h of u comma v. Compute the inverse DFT of the result. Then obtain the real part of the result and multiply the previous step by minus 1 to the power x plus y. Basic model of filtering in the frequency domain, that is g of u comma v is equal to h of u comma v into f of u comma v. H of u comma v is a filter transfer function. The objective is to find out a filter function h of u comma v that yields g of u comma v by attenuating the high frequency component f of u comma v. There are three types of filters: ideal, Butterworth and Gaussian. In frequency domain filters, low pass filtering, edges and other sharp transition of gray levels of an image contributes significantly to the high frequency components of the Fourier transform. Hence, smoothing is achieved in the frequency domain by attenuation a specified range of high frequency components. See, the basic model is g of u comma v equal to f of u, h of u comma v into f of u comma v. Objective of low pass filtering is to reduce noise, remove sharp edges and produce smooth or blurred image. Type is ideal low pass filter. Ideal low pass filter, the two dimensional ideal low pass filter has the transfer function that is at the distance which is greater than a specific distance d naught from the origin of the transform. It can be represented as h of u comma v equal to 1 when d of u comma v is less than or equal to 0, 0 when d of u comma v greater than d naught. So it will be like this: d of u comma v is equal to u minus m by 2 the whole square plus v minus n by 2 the whole square, this whole power 1 by 2. Butterworth filter, it is controlled by cutoff frequency. It is for better control and more practical than the ideal filter. Butterworth filter is an ideal filter where it follows the lower order values reach the Gaussian filter. So its filtering function is like this. And Gaussian low pass filter use the Gaussian function for best smoothing performance and most commonly used. Its transfer function is h of u comma v equal to e power minus t square u comma v divided by 2 sigma square. Its frequency domain spectrum is like this only. Sharpening, the frequency domain high pass filtering is high pass filtering processes which attenuates a low frequency components without disturbing the high frequency information. So here ideal high pass filter is like this only. Butterworth filter is having transfer function, and Gaussian high pass filter is having transfer function what we discussed earlier. And comparing this table, we are having the smoothing filters for smoothing the spectrum. Hope. Thank you.